Hi, this is Ms. Warner. We're going to continue our unit on stoichiometry, and today we're going to be talking about limiting reactant. So for a reaction, you have, suppose you have A plus B gives you C plus D. This reaction continues. A will continue to react with B, forming C and D until at some point one of these is gone, is used up. And when it is gone, the reaction will stop. So the limiting reactant is the reactant that's completely used up in the reaction. The other remaining reactants are going to be called excess. Okay? If you're practicing with UT Quest will call the excess reactant non-limiting. So what is the limiting reactant? Again, it's the reaction stops when the limiting reactant is consumed. Because there's no more reactant there, the reaction cannot continue, so it will stop. The amount of product formed is determined by the limiting reactant. So whichever reactant produces the least amount of product, that would be your limiting reactant. This is just a little analogy to kind of put it kind of in everyday terms. If you're trying to make a sandwich, and in our sandwich we're going to have 2 slices of bread, 3 pieces of lunch meat, and a slice of cheese. If you go in and you look and you say, oh, I have 6 slices of bread, I have 12 pieces of lunch meat, and I have 5 slices of cheese. What's the most number of sandwiches you can make if every sandwich has to have 2 slices of bread, everyone has to have 3 pieces of lunch meat, and 1 slice of cheese? The most sandwiches you can make would be 3 sandwiches, because after that you run out of bread. You don't have enough for any more bread because you only had 6 slices. So that means the limiting reactant is the bread. The excess reactants are the things that you have left over. You could notice that the excess reactant is less than it was in the beginning, because some of the bread, like if you look at, the lunch meat, you only have 3 pieces left because some of the pieces went into the sandwich. Same thing with the cheese. All right? So we're going to do this. It's pretty simple if you're in your kitchen doing this, but we have to do it in on paper and in chemistry lab. So let's look at this. So how do I determine which reactant is limiting? Again, suppose you have 10 molecules of hydrogen gas, and you have 7 molecules of oxygen. And so we're going to synthesize some water. So if we look at the ratio between hydrogen and water, we get that ratio from the balance equation. It's a 2-to-2 ratio. So if we had 10 molecules of hydrogen, how many molecules of water would we get? Since it's a 2-to-2, you get 10, which is what this says. If we want to look at the oxygen, between oxygen and water, the ratio is a 1-to-2. So if you have 7 molecules of oxygen, you're going to get twice as much water, so it's 14. Okay? But the problem here, this assumes when you do the oxygen that you have as much hydrogen as you need. When you go to do the hydrogen, you assume you have as much oxygen. But in this case, you don't. You are limited. So you look at your product, and the one that gives you the least amount, which is this one, that reactant then is your limiting. So hydrogen is limiting, and you get 10 molecules of water. Now, how much how much oxygen is left over? Well, if you look at the relationship between hydrogen and oxygen, it is a 2-to-1. So if you started out with 10 hydrogens, 10-to-1, you're going to be using 5 oxygen. That's what you're using. Okay, so how much do you have? Well, if you started out with 7 and you used 5, you have 2. So you have 2 molecules of oxygen in excess. Okay. Of course, we're going to be using dimensional analysis, but I wanted to kind of show you more an analogy, more using ratios of how this comes about. You will need to use dimensional analysis to show it. So this is just a little visual. These are the oxygens. I know they're the oxygens because I counted them up, and there's 7 of them, so those clearly must be the oxygen, and there's 10 grays. So when you come over here and they match up, you can count them. You end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you have your 2 excess there. All right, so there are two ways in which you can determine the limiting reactant. Method one, which is the one that I'm going to be using in the video, you just convert both reactants units to moles of one product, or after moles, you can actually convert it to the mass of that product, but you have to do the mole ratio to get there. The limiting reactant results in the smaller mass of the product. Method two, you convert one reactant to the same units as the other. If the other is smaller than your result, it's limited. If it's larger, it's in excess. This is my favorite one. If you choose to use method two, that's fine. You just still have to use dimensional analysis. You still have to show your units in your work, and you still have to have mole ratio and whatnot. So, all right, so here we go. So you have a balanced equation here, and remember the first step in stoichiometry is to make sure you have a balanced equation. I went ahead and had this previously balanced. So you normally recognize these because you have two givens here. So you have 100 grams of hydrogen and 80 grams of oxygen. So we first need to figure out, hey, you know, which one of these is limiting, and that's what the question is. So we're going to start with 100 grams of hydrogen. And we're going to, you could convert this to mole, but I look ahead, since it says what mass of water do we need, I'm going to go ahead and convert both of these to mass. So whatever units up top goes down on bottom. If you're not in moles, get to moles. 2.2. And we're doing mole ratio, moles of hydrogen, and we're going to get to water, so moles of H2O. And then remember, we get our mole ratio from the equation balance, so 2 here and a 2 here. If we stop here, answer would be in moles of water, and you could determine the limiting reactant just converting to moles, but because I know I'm going to have the mass of water, I'm just going to go ahead and do this other step here. I'm going to go ahead and set up the next question as well, so 80 grams. Oxygen. If you're not in moles, get to moles. And once you're in moles, you can go to moles of what we're looking for, which in this case is water. And there's a 1 in front of here and a 2 here. And then, of course, this last step is going to be the same. All right, so whenever you calculate this, you get, let's see, I have these previously looked up. On this one, you get 892.079, and then 80, on the 80 grams of oxygen, you get 90, I'm going to change it back to green, 90.1. All right, so which one of these gives us the least amount? The least amount is the 90.1 grams. So whatever gave us the least amount, that must be the limiting reactant. So the limiting reactant is the oxygen. Which says what mass of water can be made is going to be, you make sure to pay attention to significant digits, 90.1 grams of H2O. And the work was in the previous problem. How much excess remains? Okay, so to find out the excess, we need to think, okay, what is our limiting reactant? So we're always going to start with our limiting reactant, which is the 80 grams of oxygen. Okay, if you're not in moles, get to moles. And this time from the limiting reactant, we're going to go to moles, and then we're going to go to our excess reactant. So we do our mole ratio, and we're trying to get to H hydrogen, which is our excess, and it's a 2 to 1. All right, and since our excess is in grams, I'm going to take this to grams. All right, so 1 mole of hydrogen is 2.02 grams of hydrogen. And so when we work that out, we find that that is 10.1 grams of hydrogen. But that's not our excess. That is what is used up. So to find out how much we actually have, we need to find out, well, we started out with 100 grams. We used 10.1 grams, and so what we have left is 89.9, which is 90 grams, using proper significant digits, because with subtraction, we just look at the number of places beyond the decimal. So the answer here is 90 grams. So we go from our limiting reactant, convert to moles, get to our excess reactant, and then we will need to subtract. So let's look at this next example. Here you have 28 grams of barium oxide reacting with 140 grams of sulfuric acid to produce barium sulfate and water, which is the limiting reactant. In this case, it doesn't tell you which product to solve for, so technically you could solve for either one of those. But I'm going to look ahead and see that it's later going to want the mass of the barium sulfate, so I would solve for the barium sulfate. Right, so since we've already gone over how to work these stoichiometry problems, I'm going to go ahead and pull out the tab for the 28 grams. And then, of course, it's a little bit, erase this little part here. And, of course, the barium oxide would be up here. Typo there. All right, so we wrote down our given. If you're not in moles, convert to moles. Of course, do the mole ratio, and then we'll go ahead and convert to grams, and then you get 42.6 grams of barium sulfate. That would be if we had as much sulfuric acid as ample, like in excess, but we don't. We have 140 grams, so we need to work a second stoichiometry problem. So 2 givens, 2 stoichiometry problems. You're going to start with the 140 grams of sulfuric acid. You're not in moles, get there. Of course, do your mole ratio. Always do your mole ratio. And then we, this last step, get the grams. So we have 33 grams. So when we look at these, we have to compare the products. And the one that is the least, whatever reactant that was, that would be our limiting reactant. So our limiting reactant, of course, is the barium oxide. Right? Let's just close this back up. There we go. And you could pause the video if you needed to write down all of that. Okay. All right. I will work how much excess in grams do you expect. So we start with our amount of barium oxide. So we always are going to start with the limiting reactant when we're doing excess, and the limiting reactant was the barium oxide. So we're going to start out with 28 grams of barium oxide. If you're not in moles, get to moles. And so we need to convert this back to moles. 153.33 grams of barium oxide, 1 mole. And then we're going to do a mole ratio between the barium oxide and the excess reactant. All right, so barium oxide to moles of H2SO4, and that's the 1-to-1 ratio. And then we're going to get to grams. And the reason why I'm converting to grams is because the starting amount of sulfuric acid is in grams. If it was in moles, I would just stop it in moles. Now, whenever we calculate this, we get 17.9 as the grams. But this is what is used in the reaction. We want the excess. So the way that we do that is now we need to, next step is to do a subtract. We need to do a subtraction. So we start with what we were given, 140 grams of sulfuric acid, and we used up 17.9 grams, and so we're left with 122.1. Taking into account significant digits, it would be 122 grams of sulfuric acid is what's in excess. This concludes video 4 on stoichiometry. You should have taken high quality and in-depth notes with examples. Rewatch the videos as needed and ask questions.